Welcome to aminacademy.com. In fluid mechanics, regarding various losses in pipes, let us do some solving problem. A horizontal pipeline of 40 meter long is connected to water tank at one end and discharged freely into the atmosphere at the other end. For the first 25 meter of its length from the tank, the pipe is 150 mm diameter and its diameter is suddenly enlarged to 300 mm. The height of water level in the tank is 8 meters above the center of the pipe. Considering all losses of head which occur, determine the rate of flow. Take F equal 0.01 for both sections of the pipe. Here, let us write the given things first. Total length. Total length of pipe L equal 40 meter. Length of first pipe L1 equal 25 meter and L2 equal 40 minus 25 equal 15 meter. Dia of first pipe D1 equal 150 mm, which is equal 0.15 meter. Then dia of the second pipe D2 equal 300 mm, which is equal 0.3 meter. Height of height of water, that is H equal 8 meter. Coefficient of friction F equal 0.01. Now applying Bernoulli's equation, here this side, one side is a tank, so v squared by 2g, the velocity is 0, that is 0, and then another one is 0, then which is 0 plus 8 is the height. This side is open to the atmosphere, other side is P2 by rho g, and P1, that is V2 squared by rho g, then plus Z is 0 datum, then with all losses. Now therefore here 8 equal then here 8 equal 0 plus V2 squared by rho g plus HI, that is head loss in entrance, at entrance, head loss due to friction HF plus HF with sudden enlargement HE plus H friction due to here HF due to friction 1, and then HF due to of pipeline 2, HF2. Now we'll therefore we have where HI entrance, that is head loss at entrance, is 0.5 V1 squared by 2G. HF1 frictional loss in pipe 1 equal 4F L1 V1 squared by D1 2G. HF2 head loss due to friction in pipe 2 is 4 F L V V2 square by D2 2G. Then HE head loss due to sudden enlargement is V1 minus V2 squared by 2G. Now continuity equation. A1 V1 equal A2 V2. A is the cross section. A1 is the cross section of first pipe. A2 is the cross section of second pipe. V1 is velocity of first pipe. V2 is velocity of second pipe. Now from that we will get it V1 equal A2 V2 by A1. A2 is pi by 4 D1 square into V2 over pi by 4 D1 square. Then pi by 4 cut, so which gives d1 by d2 whole squared v2. Now d1 is 0.15, d2 is 0.3, d2 here, sorry, d2 so 0.3 over 0.15 the square v2, which is equal 0.3 by 0.15 is 2, 2 square is 4, therefore 4v2. That is, we have relation v1 equal 4v2. Now substituting this v1 value in hi equal 0.5 v1 square by 2g, so which is equal 0.5 into 4v2, because v1 equal 4v2 the square by 2g. Here 4 square is 16, then divided by 2 is 4 into 0.5, 4 square is 16, divided by 2 is 8 into 0.5 is 4, therefore 8v squared by 2g, 8v2 square by 2g, h1. Then hf1 equals 4fl squared by 2g, that is 4, f is 0.01, l is 25 into 4v2 square, which is equal by 0.15 to g. D is 0.15 to g. Then which by simplification, which gives 106.67 V2 squared by 2G. HE, sudden enlargement, is V1 minus V2 the squared by 2G equal 4V2 minus V1, 4V2 minus V2 whole squared over 2G, which is equal 9V2 squared by 2G. HF2, head loss due to friction in pipe 2, is 4 into 0.014F. L is 15 meter. V2 squared by 2G D2, that is equal, here D2 is 0.3. Then simplification will get 2 into V2 squared by 2G. Then substituting all values in equation 1, that is here we are having therefore 1 gives 8 equal V2 squared by 2G plus 8 V2 squared by 2G plus 106.7 V2 squared by 2G. Then 9 V2 squared 2G plus 2 V2 squared by 2G. So we can take out V2 squared by 2G one plus 8 plus 106.7 plus 9 plus 2 equal therefore 8 equal V2 squared by 2G 126.67. Therefore V2 equal 8 into 2 into G is 9.8 over 126.67 square root, which gives 1.113 meter per second. Therefore bit velocity at pipe 2 equal 1.113 meter per second. The rate of flow Q equal A to V2, that is pi by 4 d square into velocity is 1.113. Therefore Q equal 76.67 meter cube per second. That means we can write this one 0.07867 meter cube per second. Therefore discharge Q equal 78.67 liters per second. We have done. Please subscribe our YouTube channel.